So far with our trig work, we have been looking at finding the different trig functions for angles in quadrant 1. Today we are going to shift that and look at angles in other quadrants as well. Our first example here says let P equal -3, -5. So we're looking at the point -3, -5. It is a point on the terminal side of theta. And it says find each of the 6 trig functions of theta. So what I want you to do is picture plotting that point. So we're going to go left 3, so for -3 for x, and then down 5. And we're going to create a triangle out of that. So always move your x and y coordinates and then connect to the origin for your hypotenuse. We have a -3 for our x coordinate and a -5 for our y coordinate. Now normally when we think of making triangles we have positive numbers for our lengths, but we do have to consider what quadrant it's in. So it is important to keep those negative values on there. We're going to go ahead and find the length for our hypotenuse. So our hypotenuse squared is equal to the other 2 dimensions squared. So -3 squared plus -5 squared. So our hypotenuse will be the square root of 9 plus 25, or the square root of 34. All right, so we're going to draw that in, the square root of 34. And now we have our x, y coordinates and our hypotenuse. To find the sine, we'll start with the sine of our angle. And our angle is always going to be the one created by that hypotenuse moving towards the origin there. So the sine of theta would be the opposite side over hypotenuse. So -5 over the square root of 34. Rationalized, that would be -5 root 34 divided by 34. And they do want all 6 trig functions, so let's go ahead and do the reciprocal of that right away. Cosecant, we're going to take the reciprocal of -5 divided by the square root of 34. So we're going to get the square root of 34 divided by -5. All right, let's move on to cosine. Cosine is adjacent over hypotenuse. So in this case, -3 divided by the square root of 34. Or rationalized, -3 root 34 divided by 34. And then its reciprocal, secant. If we take the reciprocal of cosine, we've got the square root of 34 divided by -3. And then the last one, we'll do tangent and cotangent. Tangent is opposite over adjacent. In this case, -5 divided by -3, or if we simplify, just 5/3. And then cotangent will be that reciprocal 3/5. All right, let's try another one. For this one, we have the point being 1, -3. So we're going to go to the right 1 and down 3. And again, we're going to create a triangle, and this will be theta right there. All right, so we went 1 to the right and down 3. So I am going to keep those negative sign by 3 there. And let's go ahead and find the hypotenuse of that. In this picture, our hypotenuse is really just the radius of that circle. So I'll label that R. R squared is the 2 sides squared added together. So we end up with the square root of 1 plus 9, or 10. So our radius would be the square root of 10. All right. Sine, cosecant go together. So the sine would be opposite over hypotenuse. So -3 divided by the square root of 10. Rationalizing, we'd have -3 root 10 divided by 10. The cosecant is the reciprocal of sine, so the square root of 10 divided by -3. All right, cosine. Cosine is adjacent over hypotenuse, so 1 divided by root 10, or root 10 divided by 10 once it's rationalized. And then secant is our reciprocal, so root 10 over 1, or just plain root 10. Tangent is opposite over adjacent, so negative 3 divided by 1, or just negative 3, and cotangent would be negative 1/3, the reciprocal. Now, I want you to take a look. We've been using this idea of opposite adjacent, hypotenuse kind of thing. But if you look at both examples, when we found the sine, we were using the y-coordinate divided by whatever that radius or hypotenuse was. Okay, so our opposite was always the y value. For cosine, the adjacent was always the x-coordinate. So we'd have x divided by the hypotenuse, which was, in this case, the radius of our circle. And tangent was always opposite divided by adjacent, and opposite was y, adjacent was our x-coordinate. So that's a quicker way. We don't have to worry about that whole opposite adjacent hypotenuse notation. The sine will be y divided by the radius, cosine will be x divided by the radius, and tangent will be y divided by x. We mentioned a few days ago the idea of quadrantal angles. These are angles that land on an axis. So that notation that we just were using, where we said sine was y divided by r, cosine was x divided by r, and tangent was y divided by x. In this case, if we land on an axis, the easiest point to use would be just to go 1 unit from our origin. All right, so pick a point 1 unit from the origin. If we want a 0 degree or 0 radian angle, we are on the x-axis. We're going to use the coordinates 1, 0. If we are looking at a 90-degree angle, or the radians pi over 2, we are going 0 to the right and up 1. So the coordinates of this point would be 0, 1. At 180, we are going to the left 1 unit for our x-coordinate, but 0 for y. And if we are down here at 270, or at 3 pi over 2, we've gone 0 for x and negative 1 for y. And what that does is it allows us to deal with a circle that just has a radius of 1. This is called a unit circle. I've mentioned it a few times in past days. A unit circle meaning 1 unit for its radius. All right, it's asking us to find all 6 trig functions. So let's start out. The sine of 0 degrees. We said sine was y over r, and our radius, remember, we said was 1. So in this case, our value for sine would be 0 divided by 1, which is just 0. Cosecant of 0 degrees is the reciprocal. When we take 1 divided by 0, though, that is undefined. So you are going to find that in all of these quadrantal angles, some of our trig values will be undefined. All right. Looking at cosine of 0 degrees. Now we want x divided by r, so we're going to have 1 divided by radius 1. So our cosine of 0 degrees is 1. Our secant of 0 degrees is the reciprocal, which also is 1. Tangent of 0 degrees. Tangent is y over x. So in this case, 0 divided by 1, or 0. And cotangent of 0 degrees is x divided by y, 1 divided by 0, which is undefined. All right. Let's look at our 90-degree quadrantal angle. Now our x value is 0 and our y value is 1. So the sine of 90 degrees, or pi over 2, is y over radius. Our radius again is 1, so we have 1 divided by 1. The sine of 90 degrees is 1. The cosecant, its reciprocal, is also 1. Cosine of 90 degrees is x divided by r. 0 divided by 1 is 0. Secant of 90 degrees, when we do its reciprocal, again, we're dividing by 0, which makes it undefined. Tangent of 90 degrees is y divided by x. 1 divided by 0, again, that's undefined. Cotangent, though, we're going to do the reciprocal. 0 divided by 1, which is 0. All right. I'm going to pause the recording. I'd like you guys to try the last two of these. All right, let's check your work. We need the sine of 180, the cosecant of 180. Sine, we said, was y divided by r. 0 divided by 1 is 0. Cosecant, when we do its reciprocal, will be undefined. Cosine of 180 degrees. We need x divided by r. So negative 1 divided by 1. Our cosine is negative 1. Our secant, the reciprocal of that, is also negative 1. Tangent of 180 degrees. We need y divided by x. 0 divided by anything is 0. And cotangent of 180 degrees is negative 1 divided by 0, which is undefined. And our last one, the sine of 270 degrees. We want y divided by r. Negative 1 divided by 1 is negative 1. Cosecant of 270 degrees is also negative 1. Cosine, x divided by r. 0 divided by 1 is 0. Secant will be undefined. And tangent of 270 degrees is y divided by x, negative 1 divided by 0, which is undefined. But the cotangent is the reciprocal, 0 divided by negative 1, or 0. All right, so for quadrantal angles, you are going to have values like 0, 1, negative 1, and undefined for all of your trig functions. As we go through the different quadrants, it's important to notice the sign, in other words, the positive and negative sign of our 6 trig functions. So let's start over here on the right in quadrant 1. When we are in quadrant 1, any ordered pair is going to have both a positive x and a positive y value. And radius is always positive. So when we do all of our trig functions in quadrant 1, since we're taking a positive value, either x or y, divided by a radius that's positive, all of our trig functions will be positive in quadrant 1. All right, going to quadrant 2. Now a point in quadrant 2 has a negative x value, but a positive y value. So x is negative, y is positive. That means anything that deals with a y will be positive. Anything that has an x will be negative. Our radius, again, is always positive. So in this case, negatives are x, and x would be things like cosine and secant. So the cosine and the secant of that will be negative. Everything else, I should rephrase that, I guess. Let's look at them individually. The sine. We're going to have a positive y value divided by a positive r value. That will be positive. Same with cosecant. When we look at cosine, we are going to have an x value that is negative, but a positive r value. We're going to get a negative answer. Same for secant. But tangent uses y divided by x And since our y value is positive and our x value is negative, we are going to get an overall negative answer for tangent and for cotangent. So we have a negative divided by a positive, which will be negative. So in quadrant 2, the only one that's going to come out positive would be the sine and cosecant. Okay? Here we said all trig functions are positive. All right, let's look at quadrant 3. To get up to a point in quadrant 3, both x and y are negative. All right, so again, thinking about sine and cosecant. They use y divided by r, so we're going to have a negative and a positive, or positive divided by negative for cosecant. In both cases, we're going to get a negative value. For cosine and secant, we are dealing with x divided by r. So again, a negative divided by a positive or a positive divided by a negative, both will give us a negative value. But for tangent, tangent has y divided by x. So in this case, both of those are negative. A negative divided by a negative is going to come out positive. Same with cotangent. So in quadrant 3, it's the tangent and cotangent that end up being the only positive values. And last, in quadrant 4, this time our x value is positive, but our y value is negative. So the things that are dealing with x will be positive. Those dealing with y end up negative. So sine is y, which is a negative value, divided by r. Cosecant would be positive divided by negative, which is still negative. Cosine is going to be x divided by r, so positive divided by positive. And secant, same thing. And then for tangent and cotangent, our tangent is going to be y divided by x, so a negative divided by a positive, which is negative. Cotangent is the reciprocal, still negative. So for this one, the only one that came out positive was the cosine and secant piece. So in this picture, we tried to summarize all of that information. It says if theta is not a quadrantal angle, meaning it doesn't land on an axis, the sign of the trig function depends on the quadrant in which theta lies, wherever that terminal side is. In all 4 quadrants, the radius is positive, but x and y can be positive or negative depending on the quadrant. A quick way for you to remember it is to use the phrase, a smart trig class. We're going through quadrants 1, 2, 3, and 4. In quadrant 1, we have an A for all trig functions are positive. In quadrant 2, we have an S for sine, and then cosecant again goes with that. Okay, so in quadrant 2, sine is positive. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, C stands for cosine. Cosine and secant are the positive ones. All right, so a smart trig class. That will help you remember which ones are positive in each quadrant. All right, example 4, it says if the tangent of theta is less than 0. Less than 0 means negative. So look at the picture. In which quadrants would tangent be negative? Quadrant 1, all of them are positive. Okay, and quadrant 3, tangent is positive. That means in quadrants 2 and 4, our tangent would be negative. That's where we have one of our x or y's being positive and the other one negative. The next requirement is that the cosine has to be greater than 0 or positive. Cosine uses an x coordinate, and x is positive in quadrants 1 and 4. So for both of these criteria to be true, the only way that they both match is using quadrants 4. So our angle must be in quadrant 4. Our second example here, the sine of theta is less than 0. So sine is negative. That means our y-coordinate's negative, and cosine is also negative. Cosine uses x. So if you look at it that way, when x and y both have to be negative, we are in quadrant 3. Now again, you can break it down in pieces. So sine is negative, y is negative in quadrants 3 and 4, the bottom half of our circle. Cosine is negative on the left side of our circle, so in quadrants 2 and 3. So again, where they overlap would be quadrant 3. All right. What we can do with that information. It says, given that tangent of theta is negative 2/3 and the sine of theta is also less than 0 or negative, they want us to find cosine and cosecant. So again, we're going to picture what quadrant we need to be in. So tangent is negative. Tangent is negative in quadrants 2 and 4. Sine is negative in quadrants 3 and 4. So our overlap must be that we are in quadrant 4. So let's draw a picture in quadrant 4. We want to have tangent being negative 2/3. Remember, tangent is y over x. All right. The negative that's out front, you do have to pay attention to which coordinate that should go to. Is it the y or the x that's negative in quadrant 4? And if we are in quadrant 4, we are going in a positive x direction and a negative y direction to make our triangle. Okay? So our y value would have to be the negative 2, and our x value would have to be the positive 3. Finding the radius of that, r squared, remember, is same as a squared plus b squared, so 3 squared plus negative 2 squared. R will be the square root of that. 3 squared is 9, 2 squared is, negative 2 squared is 4, so we've got the square root of 13. Now they are asking us to find the cosine. Right? Cosine is our x divided by r. In this case, x was 3, and r was the square root of 13. So rationalized, we would say 3 root 13 divided by 13. Cosecant is the reciprocal of sine, and sine was y divided by r, so cosecant would be r divided by y. Our radius was the square root of 13, and we said our y-coordinate was negative 2. So negative root 13 over 2. All right, our next example. It says, given the sine is negative 12/13 and theta is in quadrant 3, find cosine and cotangent. So let's think of quadrant 3. Sine is y divided by r, and your radius is always positive. That means the y has to be our negative 12. So we're going over x, we're going down 12, and we have a radius of the square root of 13. Sorry, radius is 13. All right, so we've got our angle here. We need to figure out our x value. And x, because it's in quadrant 3, is going to be a negative value. All right, so going through Pythagorean theorem, x squared plus negative 12 squared equals 13 squared. So x squared plus 144 equals 169. Subtracting x squared would be 25. X would be positive or negative 5, but again, because it says we are in quadrant 3, we need the negative 5 version of that. All right, so we now know that x is negative 5. We can find cosine. Cosine is x divided by r, so negative 5 divided by 13. Cotangent is the reciprocal of tangent. Tangent is y over x, so cotangent would be x over y. X is -5, y is -12. We can get rid of the negatives and reduce to 5/12. All right, go ahead and pause the recording and try our last example here. All right, let's check your work. Given the tangent is 3/5 and the cosine is negative, find the cosine and the sine of theta. So tangent is positive in which quadrants? For tangent to be positive, both x and y have to be positive, which would be quadrant 1, and both x and y could be negative. That would still give me a positive tangent value. So tangent is positive also in quadrant 3. Then it says that the cosine has to be negative. Cosine is negative on the left side of my graph, my circle. So in quadrants 2 and 3. So once again, we are dealing with something in quadrant 3. All right. So if they tell me that the tangent of theta is 3/5, I'm thinking y divided by x, right? So I would think y is 3 and x is 5. But again, we are in quadrant 3. That means both of them have to be negative. So we are going -3 in this direction for x, sorry, -5 in this direction. -5 for x and -3 for y. Again, we're going to find theta there, that angle that gets us to our origin. We are asked to find cosine and sine. Both of those require us to know what the radius or hypotenuse of this triangle is. So let's go ahead and find r. R squared is -5 squared plus -3 squared. So 25 plus 9, or 34. R would be the square root of 34. All right, so cosine is x divided by r. X we said was -5. R is the square root of 34. Rationalized, we would have -5 root 34 divided by 34. The sine is y divided by r. In this case, sine would be -3 divided by the square root of 34, or again rationalized, -3 root 34 divided by 34. All right, so you guys are going to work on the green worksheet. It should say Trig-Day 3, and you are doing the circled questions on that.